Hello, my name is Angel Bringas, and now I'm going to explain the laboratory task number 2. Well, first of all, they asked us to connect four resistors on series and to connect them to a power source of 5 volts, and here's how it looks like. Then, well, we need to measure its voltage, and then using the multimeter, we need to complete this table in which we'll, first of all, we need to measure each resistance value with, obviously, with the multimeter. We calculated its voltage, we calculated its power, and we place here the measured voltage that we obtained with the multimeter for each resistance. That obviously was gonna be different. What we need to mention from this is that as we have a circuit on series, the current is gonna be always the same, but the voltage is gonna change. Now, well, it obeys the Kirchhoff's voltage law because it drops across all the resistors exactly the same as the 5 volts that we were inducting with the 5 voltage source. And well, here it can be appreciated that the sum of all these 4 volts from each resistance is equal to the 5 volts that we connected. Here is like the values of the for each resistance for the current, and well, we can appreciate that it's the same as I've mentioned because it's connected on a series circuit. And also it's calculated here analytically just to prove, and here we can say that it's the same value, well, with minimum changes on decimals, but it's normal. So this part of the experiment was done successfully correct. Then we need to make another circuit connecting three resistance in parallel, also with the voltage of 5 from the power source. And well, here is like correctly, smoothly connected because it says that it's 5.02 volts. And here we have like an image of how it looked like. Then we also did like this table in order to calculate the resistance value for each resistor. We measured the current, we calculated the current, and we calculated its power. Also, well, here the Kirchhoff's current law is correctly done and it's justified. And here we have like the voltage for each one of the three resistors, in which we get that it's the same. Why? Because on the circuits connected in parallel, the current is gonna change, but its voltage is always gonna be the same everywhere. Now to sum up on this last part, we connected a power source of 8 volts and a power source of 5 volts. We need to get a value of 13 volts total, and it was correctly done measured with the multimeter because as it's in series, we just add them as it's explaining here. And well, with the voltage source, there were problems because it cannot be directly done because the multimeter like takes the value of the higher voltage, and we cannot do that if we try to connect them in parallel. Thank you.